Let's take a look at the performance of the R32V2020 RISC CPU. Our initial goal was to replace the 8-bit CPUs used in Multicomp with a faster, more modern architecture. The CPUs used in Multicomp are the 8-bit era 1 MHz vintage style CPUs like the 6502 and the Z80. Now, Grant did overclock a lot of them, but let's just look at the base spec for those parts from their day. These processors all take 1 to 4 clocks to execute an instruction, 1 clock for a trivial instruction, and usually multiple clocks to load immediate values and things of that sort. These processors are really starved for registers. They have 1 or maybe 2, if you're lucky, registers inside of them, and that meant most operations are to and from memory. So let's go ahead and compare and contrast those processors with the R32V2020 RISC architecture and see the differences. To start with, the FPGA raw speed is around 50 MHz, which is a 20 nanosecond time, but it will take multiple clocks to do any operation. Let's take a look at why. For this, let's consider one of the more simple instructions to add 2 registers and put the result in a register. This requires multiple stages. The first stage is a program counter that gets incremented with every instruction, and we'll ignore branches for the moment. Instruction memory, in this case read-only memory, that the instruction is fetched out of and used and then decoded. Decoder stage isn't shown here. In this case, it'll get decoded into selects into the register file to select the first register and the second register to go into the ALU. And the ALU operation gets performed, which is the add, and then written back to the register file. You can see each of these stages will take time with propagation delays. The R32V2020 RISC CPU has 4 stages. These 4 stages are 4 clocks of 20 nanoseconds each for a total of 80 nanoseconds per instruction, which translates into 12.5 million instructions per second. So just off raw clock speed, we're already well over an order of magnitude faster than the 8-bit CPUs. But wait, because the 8-bit CPUs take multiple clocks per instruction, it can be 1, 2, 3, or 4 clocks. Let's maybe say it's 2 clocks. Well, that's 2 microseconds per instruction, or 500,000 instructions per second. But the RISC CPU, all instructions always take the maximum speed of the 4 stages, which is the 12.5 million instructions per second. If all the data you ever dealt with was just 8-bit data, then there wouldn't be a large advantage to having a 32-bit data size. Where the larger data size really comes in handy is dealing with the address bus. The 16 bits of addressing on a typical 8-bit CPU means 65K of memory can be addressed, but the 8 bits of the CPU data size don't allow that without multiple loads into various index registers, and this becomes very tedious with a lot of overhead to move pointers and things around for the 2 halves. Having 32 bits of data available facilitates larger address spaces without the penalties of shuffling things around in the various halves. So the only limit we face with the 32-bit RISC CPU and an FPGA is that the FPGA design limits the amount of program data stack space due to the internal BlockRAM. However, this really isn't a performance limit per se, but it really is just a capabilities limit, and we can shuffle around various resources in the FPGA or use larger FPGAs with more space if we have larger applications. What I am lacking at the moment is a benchmark that would show that performance. The difficulty is it would need to be coded in assembly language for both the 8-bit CPU and the RISC CPU. But we certainly are at well over an order of magnitude, and perhaps close to 2 orders of magnitude faster than the older 6502 based designs. And this architecture, without all of the messy indexing and pieces of registers here and there, is certainly a much simpler programming model, and having the multiple registers themselves and the ability to scratch pad in and out of various registers without moving to and from memory certainly provides another performance boost as well. Really hard to quantify at this point, wish I could. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindie where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.